Hello, welcome to Enlightning Friends. I'm so glad you're here. And you know who else I'm glad is here is Lucas Severo, Alves, and Marit Johnner, who are here today to teach us all about External Secrets Operator. Hey, y'all tell us about yourselves, please. How about Lucas, you go first?
Sure. So my name is Luca Severo. I'm a software engineer at Red Hat. I live in Hamburg, Germany, but now I'm in Brazil on vacation. uh,
Nice.
I started my career actually as a maintaining infrastructure like system administration, site reliability engineering, and then moving on into DevOps topics, making teams talk to each other and all. But eventually, open source like make my eyes bright and all, and I
Oh,
started like moving more into development and like moving more into like community work and like trying to create projects and contribute and all that. And that's why how I met Moritz online first, but yeah,
so
that's me.
oh, when you said open source made your eyes bright and you started to move over, is that something you were doing like professionally, getting your job kind of switched, or in your free time, it's what you're spending time on, or how does that work?
It was initially on my free time,
Uh
but
huh.
then I managed to do a bit on my work time, but just a bit. Like I
Okay.
managed to convince some people to let me do it.
Nice.
But now I do it full time because yeah, I work at Red Hat. So yeah,
Right on.
but not necessarily on external secrets operator, but yeah, other projects inside of Red Hat. Yeah.
Cool. And Marit, tell us about you, please.
Hello. Yeah, sure. Hi, my
Hi.
name is Moritz. Yeah, I'm also based in Hamburg. I work for a company called Form3. It's a payment processing company based in the UK. Yeah, I work as a platform engineer. I work for the compute layer, so we're building Kubernetes clusters across multiple cloud providers and on premises. It's a huge challenge and interesting. I started my career though in front development and web development, so I kind of started at the front end and then like moved my way down the stack, like did like some backend stuff, database, system administration. At some point, like bare metal, machine management and bootstrapping and that kind of stuff. And yeah, I kind of stuck with platform engineering, so everything that is like builds the foundation for a lot of product teams so they can run their applications. Yeah, I've been doing this for quite a while now. And yeah, that's actually like because Kubernetes is everywhere, and as a platform
Uh-huh.
engineer, you most of the time use Kubernetes. So that's how I kind of got involved with the open source software community, and kind of got stuck there. Took over the role as a maintainer for external secrets operator, and yeah, I guess like I've been working as a consultant, and I've been building platforms for lots of companies. And one of the first problems that you got to solve after solving that compute and storage and networking, that kind of stuff, this
Uh-huh.
second then is to manage secrets. How are you managing
Yeah.
all these credentials? And that's how I kind of got involved and met Lucas in the end.
And so, in the order of concerns of platform engineering, managing secrets is up there in terms of what you need to. That makes a lot
Yeah.
of sense. Those of y'all in chat, if you'll please say hello and where you're from, I'd love to say hi to you. And so you say you've been a platform engineer for a long time. How long is a long time? It's my understanding that platform engineering, at least the term for it is pretty new.
Yeah, that's kind of new. Yeah, so like in total, I have like more than 10 years experience in IT, and it's kind of hard to tell. I guess like my first role as a platform engineer was in 5 years ago in 2018 or so. I think that's when
Okay.
I was especially looking for like platform engineering roles, and yeah, this was like the only company that had that sort of role, so I kind of moved there. It's not only that, but also like had like a lot of interesting challenges there, so that's why I joined there. And that was like actually in the consulting role back in 2018.
Okay, cool. So y'all live in the same city, but you met for the first time at KubeCon. Which KubeCon? The most
Uh,
recent one?
EU, yeah, like
Yeah, in
literally just
Amsterdam.
in April, yeah.
So you guys both flew to Amsterdam so you could finally meet each other.
Yeah, we've been working together for like 2-3 years in 2019 or 2020. I can't remember when we started working together.
Uh-huh.
Yeah,
90, yeah.
and end of 19, I believe. So yeah, been hanging out online and virtually, but not really meeting in person.
What what do you like about KubeCon, or even dislike? What's a notable thing about KubeCon for each of you?
Meeting people in person, so that's why we
Yeah.
met. But
Uh-huh.
not only like new people as well, like trying to know people using your project and all that. So
Oh yeah.
meeting on the corridors, not necessarily on talks, and like
Mm-hmm.
just, I don't know, sharing problems and solutions to stuff. Not necessarily technical as well. So that's very nice.
Well, like in everyday life, you don't have people who you can talk to about Kubernetes. Like in my friend group, there are no other people I could talk to about Kubernetes. So it is nice to like sit at a table with people who totally get what you're excited about.
Yes.
Yeah. Uh-huh.
And
What
I saw
about
a
you, Mark?
quote from some,
Mm-hmm.
sorry, go ahead.
No, you go, please.
I saw a quote from someone like, it's very difficult to make friends when you're an adult, but like, I think Kubernetes is solving a bit of that problem as well.
Totally. We're all the
Yeah.
same kind of nerd.
Yeah.
That forms bonds. What about you, Maurice? What do you like or dislike about KubeCon?
Yeah, I guess like my whole experience has changed radically since being an open source maintainer. I guess the thing that I like the most that now you're able to connect to people that you can't really connect with that quality when you're online. Sure, you can just go to some open source software project dailies or weekly community meetings or whatnot, but it's really cool to just hang out with people in person, or just approach some people from other projects and just chat how they manage the community, what kind of problems they solve, and that kind of stuff. And you just can't do this online. You could just go there and just say hi, and it's just so easy to connect with people, and also like see some old friends that maybe maybe left the company that you've been working with, and you can just connect with them. The thing that so the most recent KubeCon, it was just huge, and this was so hard to get around. I guess the last KubeCon, the worst part was probably like the getting around. It's just so confusing where like all the rooms were and how to get there. I had so much trouble finding a toilet. I just running around for like, I don't know, 50 minutes, just couldn't find a toilet. It was pretty annoying. But yeah, apart from that, it was a great experience, especially since we were there and we had a stand with our project, and it was just so great to talk with people who use it. We just learned that people from VMware had integrated with Tanzu and deploying it and talking to so many users, and just great to get so much feedback, and it gives a lot for like all the sweat we put into the project. It just gives so much back. That's so great.
Yeah, I loved hanging out in the open source pavilion. That was kind of my default if I wasn't busy doing something else. And honestly, I almost feel guilty about it, but I went to very few talks because I feel like I could watch those again later. They're recorded, and there's so many people that I want to see and say hi to and talk to. Yeah. But let's move on to the learning portion. But before we do, I'm going to put some links in the chat. So, the first one is the link to the documentation. And I'm also, we can probably save this question for behind the board, but I'm interested in why there are two of you here. And I remember we kind of talked about it before, but I deliberately forgot so we could have this conversation, because I feel like maybe you were going to divide and conquer and each teach a different aspect. Is that what's happening? Yeah.
I think it organically moved into that in some other shows that we joined and podcasts. We kind of have some topics that one talks about and the other one talks about, and I don't know.
Okay.
We kind of like the dynamic,
Yeah. Y'all are great. So what is this Slack, the Kubernetes Slack? So I'm putting in a link to the external secrets channel in the Kubernetes Slack. So if you have any questions, especially if you're watching the recording instead of live, if you have any questions live, of course, ask them here. But later, if you have questions and you're watching the recording, that would be a great place to put your questions. And this last link, I believe, is a link to the community meeting. Is that correct?
Notes. Yes.
Community meeting notes. Okay.
And you can find the time for the community meeting and the date and all on the notes as well.
Okay, excellent. All right, so now while I start my long journey to get behind the light board there, tell us about how y'all met each other.
Yeah, sure. Maybe I can start, and Lucas, maybe you can just add some things.
Okay.
So I back in 2019, I believe it was. I was working with a consulting company, and we were building cloud native platforms for enterprisey stuff. And of course, just as I've told, you got to solve this secrets management problem at some point somehow. And at that point in time, 2019, there were like a couple of technologies you could use. You could use sealed secrets, which was at that point in time, I think, the most popular solution. And the other one, which was sort of fresh at that point in time, was Kubernetes external secrets. That's a project from GoDaddy. They released it somewhere in 2019 or so. I don't know. It was kind of fresh at that point in time. So yeah, I had it there because it looked pretty promising, and it worked very well together using like GitOps approach to managing Kubernetes YAML and all that stuff. So I went there, contributed a couple of features, and at some point I noticed that there are a lot of other operators and tools that do the very same thing. So someone opened an issue where they thought about like maybe let's just consolidate all these projects together into one project and do it well, and just take all the learnings from all the different projects and rewrite it and do it well, or integrate it into the existing solution. And that's where I met Lucas, because he was a maintainer at that point in time for the external secrets operator from Container Solutions. I think that's what the name was. I'm still confused because there are so many names with so many secrets and operators in its name.
That's the most confusing thing, because it's the same name, but it's an archived project. And we took the same name for the new project, yeah.
Oh, okay. I was confused in your story because you were like, we needed a standard. And then you mentioned that Lucas was already working for external secrets operator. Anyway, yeah. So now you just cleared that up.
Yeah, it's very confusing because there are so many different projects that pretty much do the same thing. And yeah, we just came up with a CRD definition, like with a specification how that thing we're trying to build look like, and just try to take all the different approaches that different projects had and just find the best approach. And and then we had like a lot of comments on that PR that we've created, and just try to find the best possible solution. And yeah, then the pandemic hit, and so that was sort of like my Corona project during the pandemic, and I put like a lot of time into it, and we basically had to rewrite it completely from scratch. So yeah, and now we're here like 3 years later or so, and we've put like so much time and so many contributors. It's insane. I've never imagined that at that point in time. That I think we're now like 230-ish contributors to the project.
Amazing.
Yeah, it's huge.
Yeah. I some of that I might want to capture on the board, because I do love knowing about how things were before your project existed. But basically, it sounds like a complex mess. It's a pretty short answer. Like we have a comment from Code with Sean's here, said, I thought those circles Whitney's wiping off are on my screen. Oh, yeah. I'll clean your screen from over here, Code with Sean. And I'm sorry, Maurice, what were you saying?
Yeah, that's well put. It's a mess. So yeah, but the interesting thing about the project is because there were like so many projects and so many different people involved. I think like External Secrets Operator, the open source project itself, is very different from a lot of other projects, because other projects, let's pick, for example, Caverno. There's a company behind it. They developed it, and then at some point they open sourced it and contributed to the CNCF. And this is like a External Secrets Operator is an purely community-driven project. We have like all the maintainers here are like every single one is from a different company, and that probably also explains why we have like so many different contributors from like so many different companies, because it pretty much is a community, and that's probably like based on the history, because it's merged from different projects and so on. So I think like that's a very unique thing.
It started like that, right, from the beginning. Yeah,
that's cool.
We had a lot of projects doing the same thing, and we like from the beginning we wanted something unified, but like from people from the other projects. Yeah.
So
Yeah.
before external secrets operator, things were a mess. But let's elaborate on that mess a little bit. That's so we can to help us understand the problem that it's solving.
Yeah, sure. I guess like that's the hardest part, where to start. Maybe we just take a step back before we like talk about how the operator works and all that stuff.
Yes.
Maybe let's start with like secrets management or secret management, like as a topic in general. What the problem is and how people like or companies typically solve that problem. I don't know. Maybe Lucas. I just talk so much. Maybe you can continue.
Yeah, sure. Yeah. So secrets management, like, it's a very loaded like concept, like because it actually is about everything related to secrets. So the whole life cycle, like who creates the secret, how it is created, how do you rotate the secret, how do you distribute the secret, what happens if secrets leak, how, like, what tools are you using, like for the management or for the synchronization and everything. So everything around the life cycle and like how you deal and your organizations deals with secrets will be inside secret management. And this is interesting because then external secrets operator, like sometimes people or like on events or something like that, people say, okay, it's a secrets management solution, but it's a tooling. It's a tool that you use. It's a tool that gives you a toolkit to deal with secrets management, but it's inside secrets management, but dealing with a very specific problem of synchronization of secrets.
So I want to back up a little bit, and so you very quickly rattled off like what does secrets management mean and all these different aspects of secret management.
Yeah.
And I think I want to write that little list on here so we can to help understand the complexity that we're trying to untangle here.
Okay, we can list those. So like the creation of secrets.
Okay.
The rotation of secrets. The deletion of secrets. So the whole life cycle of secrets. You can like create you can group those.
Yep. Will do. I'm listening.
Let me remember what I said. It's also organizational. So how do you distribute secrets? How do you give access to secrets? How do you deal with problems related to secrets, like when secrets leak? Moritz, did I forget something?
Yeah, no. That sounds good. I guess maybe just to add, so you have like different types of secrets as well. You have like passwords, API keys, you have certificates. Yeah, I think that like these
tokens.
Tokens.
Passwords. Yeah. Even like I saw, like when you're translating the word, sometimes in some languages they just call them credentials. But some secrets are not credentials, like encryption keys. It's not a credential, right? But it's a secret. Yeah. So you can also define what a secret is. Like this is interesting to me because I have to interact with like 3 languages: German, English, and Portuguese. And in Portuguese, you don't have like a good word like in English, like to describe like this is a secret. We actually say the whole thing like credentials, tokens, passwords, I don't know, certificates. So in English, you have this word. Okay, all of those are secrets. Yeah. Defining.
Another aspect would be like the problem of storage. So you need to store these secrets safely, and you need to transmit them safely to the consumer of that secret. If you have like a certificate and a private key, you need to the application, say a RESTful API that runs on HTTPS web server, needs the private key and the certificate, and they need to get there somehow. So what companies typically do is that they have some sort of a vault, like a conceptual vault, where they store everything related to a secret, a credential, API key. Literally, like everything is just stored in this vault. So this is how companies typically solve that problem of storage, access control, and the whole lifecycle management problem. So this could be tools like HashiCorp Vault, AWS Secrets Manager. There are like different tools out there with like different focuses. Could be like LastPass or OnePassword that is more oriented towards non-technical users. Some are just simple APIs where you just, it's just basically a key value store where you store secrets. So this is what typically all the companies have in place to store their secrets. And this is the assumption that external secrets operator is built on top.
Yeah.
External secrets operator is built on top of Vault. The idea of a Vault.
Like on top of this conceptual vault. So we make the assumption that all the secrets and credentials are stored in a vault.
Okay. And can we then define exactly what a vault is?
It is a system that stores secrets safely, and it has some API that allows you to interact with it.
Yeah.
Could be a UI, could be programmatic, some HTTP RESTful API, whatever.
Okay.
And this is a dependency. Like you first need to choose what vault you want to use. So let's say HashiCorp Vault. And then after that, you're probably choosing a way to synchronize those secrets on the safe vault to your Kubernetes secrets, because you're using Kubernetes and you just want the quality of life of using Kubernetes secrets.
Okay. So external secret operator is built on top of a vault that makes an assumption that you are using a vault. Is that what you're telling me? Okay.
Yeah, exactly.
Yes. The other topic that I think is interesting in this beginning, like to define, maybe Maurizio, you want to talk a bit about it, like the attributes that credentials have?
Yeah, sure. Let me think. Oh yeah, some credentials. Maybe let's just wait.
Thank you, sorry.
We're just jumping around.
You're excited. I'm excited too. I get it. So will you restate, Lucas, what you said? Hey, I think we should mention
what attributes credentials or like secrets have usually.
Okay.
Like, because we defined what like secret management is, and then we defined what secrets are, but we didn't define like how, I don't know, what things secrets can have or not have and this kind of stuff.
Yeah. So one attribute would be like an expiry date of a secret. Some secrets they're valid like forever. You can use them in 100 years from now, or maybe not. Some others they have a lifetime, say like certificates or so. They have some end time, and after that they cannot be used. I think that would be like one attribute. The expiry date. The second one would be like the mode how they are created. Some credentials are created manually, so you have like some operator clicking through some UIs and generating some token or whatever, and other secrets are generated automatically as part of, say, a CI pipeline or as like some sort of automatic process. It could be also like a rotation that kicks in at some point in time, and then it renews a given set of credentials. What else? Lucas, anything on your mind?
Dependency.
Oh, yeah, good one.
So, yeah, you could have, like, you're mentioning certificates. So you have to sign certificates. You have to deliver it to a certificate authority. And you have to sign it and bring it back. And then you need to be like sure that the certificate authority is available and that is, I don't know, delivering the thing like as fast as possible for you to use the secret. Then you can have dependencies that are internal, like on tooling or maybe on people, depending on how your organization works. So dependency is a big topic as well, especially if you're talking about, I don't know, if a secret leaks or a bunch of secrets are leaking in your company, and you have to rotate everything, and then you need to be sure that this is quick, and then you have a lot of dependencies, and then you're stuck maybe. So yeah.
Okay.
This is a big topic. What else? And then who is the consumer? If you're using like as a user, like we were talking about, like passwords in 1Pass or something like that, or an application using a secret like an API token or something like that. So you have multiple types of consumers of secrets.
Yeah, the consumer is quite important. When you think about it, if you have a secret, say on your laptop, on your working machine, that you use to, say, log into some Grafana dashboard, some monitoring dashboard that you have, different rules apply because this secret is like on your laptop, and as such, it may be possible that you get an email from some evil adversary, and you click on a link, and then suddenly he's able to execute something on your machine and exfiltrate that secret. So in a different environment, that may maybe not the concern for the security team. So if it's like in a different environment, different rules apply for this particular secret. May it be, typically wherever a human being is, you don't want to have secrets that do not have an expiry date. So they should expire within, say, 2 hours or so, simply because of that threat that someone is able to take over your machine.
Yeah.
I'm learning a lot about security. I just got through a bunch of episodes about policy, but what I do know is the weakest points of a system are anywhere a human exists in the system. Like, yeah.
Yes.
Yeah.
For sure. Yeah.
So we said, who's the consumer? So it's like a human versus a process. Is that capture that well enough, or did you want to be more specific?
Yeah.
Okay.
No, that's perfect.
Okay.
That's perfect. Yeah. A service or an application process. Yeah. All synonyms. Yeah.
Excellent. Yeah. Depending on the context. Yes.
Yeah.
So yeah, with this. Oh yeah, go ahead, please. I just wanted to keep on.
Oh yeah, I was only going to recap that, like, already in the first, 10 minutes we've been talking about this, the complexity here is vast. I can see.
Yeah, maybe we can just make an example of how not to manage secrets. So what you typically not want to do is to, just go into Slack and send someone some shared secret for your monitoring dashboard. So that's something you should not do. I guess that's obvious, but people still do it today.
I may or may not have received a secret in Slack in the past month. nothing VMware related. Let me say that.
Yeah, sure. So this is what you typically shouldn't do. But in a perfect world, you would have everything stored in this vault, and you would have some rotation policies applied to a given secret. So it automatically is recreated, refreshed, and then pushed to the consumer, and will be renewed there as well. So this is like the perfect world. It in reality, it looks very different, but this is the assumption that ESO is built upon. So what ESO does, it simply just is an operator that runs inside Kubernetes, and it talks to this Vault API and says, give me that secret. And then it stores that secret as a secret resource within Kubernetes. Sorry, we have to say the word secret so many times. It will be. If you're not yet annoyed, you will be annoyed in a couple of seconds.
I'm gonna start writing ESO only instead of writing on external secrets operator over and over again.
Yes.
But I did want to, since this is the definition, I wanted to write it out. So external secrets operator is, repeat it again, please, Moritz.
Is a Kubernetes operator.
Okay.
That, I guess this would be a very long sentence if I repeat it literally. So it is a Kubernetes operator that talks to that vault, pulls a secret, and stores it in Kubernetes.
Yeah.
talks to a Vault API. And then I feel like you listed 3 things. We can make it a list and then it doesn't feel like a long sentence.
Okay.
And what?
Reads a secret or retrieves a secret from the vault and stores it in Kubernetes.
The idea is that users and administrators, like, they are used to use Kubernetes secrets, like for integrations and for like their applications and all that. But they also want their secrets like in a very established solution like HashiCorp Vault or AWS Secrets Manager. So they want to bring those words like together, basically, for quality of life, but also security.
Do we want to say something about like managing the secret once it's already in Kubernetes as part of this definition?
Yeah, it also manages its life cycle. So whenever a secret gets rotated inside the vault, this will be reflected inside the cluster as well at some point.
So it doesn't manage the life cycle of the secret itself. It manages the life cycle of the secret in Kubernetes.
Yeah, so
it
is very simply put, it is a polling mechanism. So every n seconds, say every 15 seconds, it asks the vault, so hey, give me that secret. If it has changed, it will update the Kubernetes secret resource. So that rotation inside the vault will then propagate into your cluster.
Cool. Yeah. I'm going to put a box around this. We feel good?
Sounds good.
Yeah. Do we want to draw the diagram of this?
Yeah, sounds good.
Excellent.
So how do I give instructions to draw the diagram?
Make a circle in the middle.
What? Tell me who are the main players in this diagram overall? Like, what are we?
I think we can have a box that is the Kubernetes cluster. We can have a box that is the external provider, the vault, that we will talk to. And
we need a human in there, maybe, and a user?
I would separate that. I would do that then afterwards. So I would say, like, in the center we have ESO, and then an arrow up where the Vault API is, because it pulls that data from Vault, and then an arrow maybe to the left or to the right to a Kubernetes secret resource. So
would a Vault be represented like a database, like with the?
Sure, why not? Yeah.
Like this.
Yeah.
Okay.
Yeah, sounds good.
Or, I mean, you know what a vault should look like? Is it as a literal bank vault? We can do that.
If you can draw
like
that, that's perfect.
I mean, it's a cube. I can do a cube. I learned to do this in 3rd grade. All right, there's our vault. It looks like a vault, right?
Yeah.
And it has a circle in it. Okay.
Yeah, perfect.
Cool.
or a dryer or a washing machine. Okay, so we have a vault, and then we have ESO, and you want ESO below?
Yep, sounds good.
Okay. Cool. And then a Kubernetes cluster.
I would maybe just make a what type pick. So I would just make something, maybe a box that represents a Kubernetes secret.
Okay.
So like a Kubernetes secret resource. Because it reads from Vault and then it writes it into the Kubernetes secret resource. So
okay.
Sort of
Carlos is here. Hi, Carlos. Carlos says Whitney is the best artist I know, which I think means Carlos doesn't know very many artists. A lot of my friends are artists. Like my degree's in fine art, but it's in photography. So So all my art friends think I'm wildly technical, and then the people who know me but not very artistic because they're truly artistic, you know. And all my tech friends think I'm wildly artistic, but not necessarily super technical. Um, uh, Carlos says ESO is an acronym that is growing on me. Yeah,
Nice.
it's acronyms. Yeah. I'm not sold on them generally as a new learner, but as a person who has to write things, the same words on the whiteboard over and over again, I can get behind an acronym. So this is our Kubernetes Secrets resource.
Yes.
Cool. Got it?
Then an arrow.
Yeah, one arrow flag from ESO upwards towards the vault.
Uh-huh.
So that's the read. So the
Okay.
read from vault.
Mm-hmm. Uh-huh.
And then another arrow from ESO to the Kubernetes secret resource, and that's the write.
Got it. And then we have the same secret in here, right? But it's not as Kubernetes, right?
Carlos Santana wrote, every time I read ESO and I think of queso, like the Spanish word for cheese. Perfect. That's good. That's a good one.
Oh, no, I won't ever not.
Now we need a new logo.
Yeah.
And maybe some nachos with cheese. That would be perfect.
Yeah.
All right. So so ESO our queso is reading from the vault. It's it's pulling the secret, and then I'm gonna make this and then it's making the Kubernetes resource that has the actual secret as part of it. So if this, yeah.
Yeah,
we haven't got that far yet. Yeah.
Yeah, I find that write written between ESO and Vault a little bit misleading. I guess like technically it's written in memory or so. It's just a thing that is
okay
in flight. So I would just maybe just remove the write.
What if we say pool? P-U-L-L. Pool.
Yeah. Yeah.
Cool.
So
you feel okay about that?
The yellow box on the right.
Is
it meant to be the Kubernetes cluster?
No, it's just the secret resource.
Okay.
We have more. Carlos says they're doing some work to register Argo CD remote cluster, and these are Kubernetes secrets, and they could be injected into Vault or AWS Secret Manager. Is that a question?
Just a question. So maybe I'm just wondering. So you're pushing them into Vault. So there's like a. Well, I don't know. I'm just thinking loud.
So yeah, it sounds like they're starting as Kubernetes secrets, and they want to be injected into Vault. But it's meant to go.
New feature.
We actually also have covered that use case. So like what we have described now is the pull variant. So we read and pull the secret from Vault and store it as a secret resource. But we can also do this vice versa. So we read from a Kubernetes secret resource and push that into the Vault, or write that into the Vault. So this is like another use case that we've covered. Yeah,
it's still in alpha, but yeah, it's a feature that we have now. But
yeah, it's still in alpha. I'm not sure if we should draw that as well. Maybe just mention it quickly. We also do it vice versa, and we also have like a third use case, which allows users to generate secrets, like within Kubernetes without having a Vault, and then you can just generate inside a cluster and push them somewhere if you desire to.
Yeah. We have Jerome. Hello, Jerome. Thanks for being here. Oh no. So what's a real life use case when you want to push to Vault. I mean, isn't that what you just described, Carlos?
Yeah, I think so. I guess like
Yeah.
the real you have like different use cases. I guess it's not necessarily like pushing secrets to Vault, but generally having the concept or the option to push secrets somewhere is helpful when you have like a like a multi-cluster setup. So you have maybe like one central, let's call it like a tooling or operations cluster that bootstraps other clusters, workload clusters, then you maybe need to inject secrets into those clusters. So that's where this push secret thing comes into play. You can also like push secrets into a vault, like HashiCorp Vaults or AWS Secrets Manager or what have you, and could do like potentially like a cross-region synchronization or cross-provider synchronization. So you can basically build up chain. You store something inside, say, HashiCorp Vault, and then you replicate it into AWS Secrets Manager. You can replicate then into Azure Key Vault and replicate into GCP Secret Manager or some stuff like that. I've heard that some users are doing that, so they like have secrets. By stored in one cloud provider API, and then they just replicate it using ESO into different cloud providers.
Super cool. We have Scott Rosenberg here too. The gang's all here. We use push a lot. It's great in cluster API or other operators that generate secrets. You can give users access to the kubeconfig via Vault that way.
Yeah. Just to be clear to people that are not familiar with External Secrets Operator and like the providers and all, it's just that we consider Kubernetes a provider for us, like a vault. It's not a vault, but like quote unquote a vault. So that's why we can read from other Kubernetes clusters and push into other Kubernetes clusters as well. But Moritz was talking about like having a tooling cluster, a workloads cluster.
Okay. So
but we're far from that on that diagram. I don't think we
Okay, don't add it here. But
no.
A vault could be like HashiCorp, it could be Kubernetes, it could be other things, other Vault.
AWS Secret Management, Azure Key Vault,
Yeah, we have like 15 providers. That's so we internally, like project internally, we call those providers. These like Vault APIs.
Okay.
15-ish of them or 16. I don't really know. I gotta look it up, but it's a lot. It's many different APIs that we support.
Yeah. Will you just give me so Kubernetes is one of them, right?
Yes.
Okay, and then who? And then HashiCorp, and then what else?
AWS
just like a couple more. Okay.
Yeah, AWS Secrets Manager, GCP Secret Manager, Azure Key Vault.
Okay. Cool. GCP, Azure, etc. Cool.
Yep.
So far in our diagram, our queso has read the vault, read the secrets, and pulled it into the ESO, and now somehow it's going to get the secret over to our into a Kubernetes resource. How do you want to depict that?
Maybe just make an arrow from ESO to that Kubernetes secret resource.
Okay.
That should be
cool.
Should be enough.
And then, yeah, okay, cool. And then the secret is represented by this pink square. It goes over here. We did it, you guys.
Perfect. Nice.
Yeah, it's beautiful. How do you feel about it, Lucas?
Good.
That long pause does not give me confidence.
No, I feel good.
Carlos says, my use case for Argo CD is a platform team creates clusters and stores the clusters info into Vault, and they get populated into the Argo CD server. And that's via Kubernetes secrets, right? Yeah, cool. And Whitney wants to draw a cheese under queso. I do. Did you already see I wrote the QUE part of queso?
I'm actually considering to change the logo. That would be so awesome to have like a nacho with a lot of cheese dripping from it and make it a queso.
Right.
Unfortunately, I don't know an artist, but yeah, maybe, maybe someone knows.
Oh, I know plenty. I can make that happen. All right. Wonderful. So where else should we go from here? Or Lucas, do you have any ideas to improve upon this drawing?
No, I think it's nice. The thing is, there are many topologies that you can have with ESO, and then a lot comes to mind. But this is the simple one. I don't think it makes sense to draw the complicated ones. Like it's too much to draw, and then we cannot tackle the other stuff.
Okay.
Yeah, this is a way too complex topic to touch on, like multi-tenant setup scenarios for like large organizations, how you secure that and stuff like that. I think that's just 2, 3, 4 steps ahead, I guess. Maybe it makes sense to talk about how the Kubernetes CRD API looks like.
Yes, or maybe just mentioning that the two important ones and like explain like what they do specifically.
Yeah.
Okay. So
the first one.
Wait, please. To help satisfy the fact that this is a simple use case, I wrote there are many topologies. Here's a simple example. Can also do multi-tenancy and geo-replication, for example. Yeah? So we can capture that. We didn't capture everything, you know? Does that sound good?
Yes.
Okay.
Yep.
And then we have Carlos. One aspect of this is you can set up a global RBAC rule. No one's allowed to write and update secrets. Only the service account of ESO can write the secrets.
Yeah, you can have that.
Yeah, that's awesome. Cool. So now we're going to talk about ESO custom resources.
Yeah.
Okay.
I think the first one we can start talking about is the secret store, just because you're probably creating it first when using external secrets operator. Secret store, or SS for short, so we don't have to write it every time.
Okay.
And this custom resource, it's basically to let the operator know how to communicate with the external provider, with your vault. So basically, if it's HashiCorp Vault, you'll have like the URL that is the URL that talks to your Vault API. You have like authentication information. So if you're using service account authentication or app role or something like that, so how the external secrets operator will authenticate to the vault. And also, what more, Moritz?
Yeah, so the secret store basically represents the vault, like for ESO inside Kubernetes, and it deals or contains information such as which provider to use. Do you want to use HashiCorp Vault, AWS Secrets Manager, and so on and so on. The authentication mechanism, as Lucas just mentioned, there's some like provider-specific configuration fields, flags, settings that you can tune.
Yeah, for AWS, for example, you have to set the region as well and this kind of stuff. So provider-specific configuration.
Yeah, but really the most important point is like which provider to use, which authentication mechanism to use. Yeah, that's pretty much it.
Yeah.
Yeah.
Carlos says one cool thing about CRs is that they can be configured with a scope of AWS access to AWS Secret Manager using EKS or RSA. I don't know what the last thing is.
IAM roles for service accounts.
Yeah.
Okay, got it.
That's an AWS
workload identity.
Another acronym, perfect.
That's what this industry needs.
Yeah. So that's actually one thing that I wanted to talk about, because like authentication, there are so many authentication options that you have. I guess typically like the best thing to use when it comes to authentication when using ESO, but also like other open source project like Cert Manager and external DNS, Ingress Nginx, and all that, is that you use a service account that is used as an authentication token to authenticate with a cloud provider. So this is what ESO can do. It just reads a Kubernetes service account, throws that against AWS, and as a result, you get like temporary credentials that you then can use to read secrets from AWS Secrets Manager. And like pretty much
Nice.
all different providers support that, HashiCorp Vault, AWS, blah, 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 and so on and so forth. And this EKS IRSA that Carlos Santana mentioned is pretty much that thing. You use a service account and exchange that for temporary credentials.
Excellent.
Yeah. Yeah, the idea is that like you have that chicken egg problem. Like the first secret that you have to create, like before external secrets operator exists on your cluster, and then in a way you can get rid of that with IRSA or with the workload identity for short.
Okay.
So this process of like having the cloud identity be related to your identity inside the cluster, your service account.
Like using Argo CD to manage your Argo CD. Yeah, something like that. We have, Carlos says, don't use hard-coded cloud keys.
Yeah, don't do that.
Say don't use hard-coded anything. Yeah. It's also great that ESO has both namespace scoped and cluster scoped variants.
Yeah, that's
all those resources.
Yeah. So you have the secret store resource, but you also have this cluster scoped cluster secret store resource, which is cluster global and can be used from all the namespaces basically. That allows you to support these multi-tenant scenarios where you have like one shared cluster secret store, and then different workloads, different teams, whatever, you really can then reference that cluster secret store and use its authentication mechanisms to pull in secrets from that particular source.
Yeah.
Cool. So what's the other? You said there were two custom resources you wanted to mention.
And then the thing that most teams will actually write is the YAML, right? The external secret.
Okay, external secret.
Or ES, yeah. And basically, this one, like you have a lot of fields, and you're basically saying, okay, you're going to bring up a value from this secret on the external provider, and you're going to write it into this other secret inside the Kubernetes cluster with this name in this field and all that. So you can configure how to bring the data to your cluster, that secret data. So one item there on the list can be also how often to bring the secret data. How to transform, how to template this data if you want to. Because we support Golang templating. So basically, if you want like a config file with like some structure like YAML or JSON or something like that, you can also like just bring up the values from the external provider and put it there. So how to template the data.
Okay, so it says take this secret from the vault and make this Kubernetes secret with this name, and then other things. Yes. Cool.
How often to do that?
Other fields. BS. So then we have how often, and you said something about templating.
Yeah, how to template it.
Yeah. And that has everything to do with who's going to access, like who's going to access the secret, what form, what do they want it to look like, right?
Yes.
Yeah.
Exactly.
Cool.
Some applications, they require a specific format of the credentials. Let's say pick an example. Maybe for instance, Grafana. If you deploy that as an application in your Kubernetes cluster, it requires some sort of YAML file mounted mounted on a container, and that YAML file contains secrets and like all sorts of different things. And an external secret resource allows you to, one, fetch the secrets from the vault, and two, define the resulting structure, how that, that YAML document that Grafana will consume should look like. So it then has like, I don't know, it's just a simple Golang templating string where you can just do all the good stuff that you can do with templating, iterate over stuff and so on. You can build your own YAML structure out of that.
cool.
That just allows developers or administrators to build the secrets that they need or that their application needs without building some sort of shell script that kind of brings everything in place. So you can just do everything inside this custom resource.
Yeah. I don't know how to properly phrase this one for the board, but like one thing that I think it's very nice and a lot of people use is like getting all secrets with specific prefix or suffix, or like following a regex and putting that on a secret,
Yeah.
It's also something that
parameterize almost which secrets are being pulled.
Yeah, so there are like two different
two
different like modes that this external secret runs on. One is to explicitly define the keys inside the vault, like pull some certificate or some private key, whatever. And the other mode of operation is that ESO basically finds a list of secrets. You could say, I don't know, like fetch all secrets that have say the tag environment equals development or team equals backend. And it pulls in like all the secrets that match that criteria that can be based on tags if the provider supports it. It could be based on the name, on the prefix, like a specific path prefix to the secret. And then ESO figures out what is relevant, pulls that data, and makes that available.
Can pull a dynamic list. Does that sound good?
Yeah, sounds good.
Yeah.
We have another comment from Scott who says ESO also supports the service binding specification now, making integrating backend services much easier and secure now for Kubernetes applications.
Yeah, that's right. Cool. I'm not too familiar with the service bindings, but I know that there was this PR. I'm not sure if it was from Scott or from someone else. I just can't remember. But yeah, good point.
Nice.
Yeah.
Is Scott a contributor on the project?
Could be. I'm not sure. I know that Carlos definitely opened up an issue and made a PR at least. That's from what I'm not sure about Scott. Could be. I'm just not so good with names, so sorry about that.
Oh, that's okay. Carlos and Scott are both wonderful humans. They both have actually been guests on Enlightning.
Nice.
Carlos is a maintainer on Knative, or was, and he taught about Knative serving, and Scott taught about Cap Controller, which is part of the Carvel suite of tools.
Oh yeah, nice.
Yeah.
Cool.
So hint, if you want to come be a guest, like be in the chat on future shows, come hang out. Yeah. Great. So external secret, did you want to mention any other fields in the external secret about how often and how to template? And of course,
there's some other stuff, but I think these are like the important ones that we can list, on the board.
Cool.
So these two are the original custom resources that we had. And of course, as Scott mentioned, we have like cluster scoped and namespace scoped for both of those. And with those, you can already do a lot of topologies, a lot of setups, multi-tenant or not, in your cluster. You can already get started. Like you write a YAML for your secret store, you see what you need there, and then you write a YAML for your external secret, apply those, and things will start happening. Yeah.
Cool. We have some chat. Scott says they're not a contributor, but they've opened a bunch of issues and they use it a lot.
Nice.
That issue in particular, when you said Scott, and I thought maybe you meant Scott in the chat, was opened by Scott Andrews.
Yeah, the other Scott. I see.
Another Scott. And Carlos said it's a privilege to be a guest on the show. Yes, it's a privilege to have you, Carlos. All right. What's next?
What's next? Maybe let's just add one more thing to the external secret. So what's also present there is that it basically contains a pointer, like a reference to the secret store above. So maybe you could just add a arrow to the top to just
I guess
make that obvious.
Reference to secret store would be one of the fields, yeah.
Yeah.
And I'll draw your arrow too, or it's
yeah.
Cool.
Lucas, are there chickens on that farm? Could that be the case?
Yes.
Okay, I think I hear them. I was just wondering, what is going like? Pock, 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 pock.
I'm sorry.
Oh, that's
Don't
perfect.
be sorry.
That's perfect.
Those of you watching, Lucas said he's on vacation in Brazil, but he's actually on a farm right now. So there are cows,
a lot of
monkeys,
animals.
Yeah, snakes,
dogs and cats.
Yeah,
and chickens.
And chickens apparently. Okay. Cool. I'm listening.
Cool, yeah. I guess like
I'm thinking if we...
Oh, yeah,
go ahead.
Okay. Yeah. One more thing to add to the external secret. One thing that I've missed is the ability to extract structured data out of the vault. So I guess that will be one point to add: extract structured data. How that works, or rather, like what the use case is that some providers allow you to store JSON, YAML, even binary data inside that vault, and ESO is able to extract structured data, like specifically about JSON. I see the chickens in the chat. Perfect.
And Napalm's here too. It's a good day. Hi, Napalm. Thanks so much for being here. So what's the use case for? Why would you want to do that?
Yeah. So sometimes you just want to have like one key in a vault that says, I don't know, team front end environment development or so, and there you store like everything that is relevant for that particular application. Maybe this could be because of cost implications. Maybe some providers charge you for the number of secrets that you store, or like for like other reasons, just like organizational reasons, because it's like tedious to set up so many different keys inside that vault. So maybe you just want to store like all the secrets that belong together, say like a certificate and a private key, or maybe just database credentials, like which host to connect with, which port to use, username, password, like all that kind of stuff. So that's why you have like structured data oftentimes stored inside a vault, and ESO allows you to not only pull that data, you can also extract information out of it. You can say like, I want to have only the username and the password, and everything else is not relevant for that application.
Yeah.
So that gives more granular control over what gets pulled.
Yeah.
Cool.
Yeah. Cool. I'm thinking maybe, do we want to talk about the alpha features as well? The push and the generator in the board?
Yeah, I guess we still have some place left, so let's go.
Yeah, we could talk about alpha features. We could also draw out some of the more complex use cases that y'all alluded to if we have space. So those are, but alpha features is great. Is alpha features fit here, or should I put it up here?
I think it will be probably like as big as the Vault ESO Kubernetes, the Queso diagram, I guess.
Okay,
that one,
so
exactly.
Put it up here. Yeah, cool. Excellent.
Yeah, speaking about alpha, beta, and all that stuff, so we follow basically the same support policy that Kubernetes has. So everything that is beta will be like every changes that we do will be forwards compatible, and we are not going to deprecate beta features. In fact, like even the old alpha features that we've had, we already provided an upgrade path for users so they can just move on towards the currently, like the external secret and secret store resources, which are currently in beta. So we provided an upgrade path for alpha users. And moving on towards a GA release, sure, we have to provide an upgrade a path, which is just part of the support policy that we have. And the currently
Nice.
the features that we have today, the alpha features. So technically, we don't have to provide an upgrade path, but I guess we, like, our first and most important goal is to not break users. Like similarly, like for Linux kernel just provides that guarantee more or less.
Yeah.
We just don't want to break users' user experience. So even if the features in alpha, we probably provide an upgrade path if it's not too much work, too much effort, too much pain to work through. So yeah.
I want to, before we jump into alpha features, I want to acknowledge Napalm's comments. Napalm says they've been ranting about secret management to anyone that will listen this week. Why does it have to slow down the developer feedback loop, messing with all these environment variables, configuration files, etc.? There has to be a better way.
It's
ESO.
ESO.
No. But it's complex, yes.
Yeah, it's very complex, and like especially like setting up all the access control for secrets in place, and like getting all the processes right. It just takes a lot of time and a lot of effort to get that right. Yeah, like from my past experience, discussing with InfoSec people, like what tool to use, how to set up ESO, even if you're allowed to use ESO or not, is most of the time just a very hard discussion you have to go through. Yeah, it is slow, like absolutely, and but it's very important to get that straight, because otherwise, you know, the companies is at risk if a secret leaks to the public, or you know, there's just like a lot of risk if you don't get the secret management right. So it makes sense. I get it. It's a lot of effort, like from an application developer's perspective. You have to like set up so many things.
Yeah, but it's also like when we say it's hard, it's also way harder when we are bootstrapping a project from the beginning. But then when we have everything set up, like ESO also makes it a lot easier, because you're just messing around with references and not with the secrets itself. And then the like security people feel safe, but also you can have developers create external secrets and then have something for them to do. So yeah.
There's a response from Napalm. Agreed, but I want just a lightweight REST service that stores my secrets safely, period. Vault is a heavy beast, and I frankly don't want to have to manage it. Yeah, I agree. I also don't want to manage like any software, any thing in the world. It's just a lot of pain to work through, especially with Vault. Like it's as usual if you have stateful workloads, and especially if they store all the secrets, like it's a pain to work through. So if you have the ability to, you know, consume cloud provider APIs, it's just so much simpler. You can just consume a service and don't care about all the operating intricacies.
Remind me, Napalm, what's your position right now? What's your job title that you're having to deal with setting up secrets management? Okay, I wrote alpha features backwards compatible, and ESO project promises not to break existing stuff. Usually in tech, we don't say such harsh language like a promise, but yeah. Does that capture what your intro to your alpha features? Promises to do, yeah.
Can you repeat the
Oh, alpha features backwards compatible, and the pink one is ESO project promises not to break existing stuff.
Promises?
Yeah, that's
a little bit too much. So we have a support policy, and in which we clearly state that everything in beta and beyond will have like an upgrade path. For alpha, we don't provide that guarantee, but you know, because we don't want to
try
break our users, we probably provide an upgrade path. But this is a probable, you know, if a secret is just, you know, turns out to be a bad idea, we may drop support for it entirely. potentially.
Uh-huh.
So we don't want to promise anything that we're so once something is in beta, we're definitely going to support it in the long term, in the long run. But for alpha, not so much. Though I must say, like the alpha features that we have today, they look pretty solid, and we got like good feedback from the community. So I don't think we're going to stop supporting them. So maybe we make substantial changes to them. So
Yeah.
Again, don't want to promise anything. So we got to see how everything turns out.
The thing about alpha is that we don't have to, but it's good to take advantage of it being in alpha, so we can make it a bit like look better. Like we notice that this field doesn't make sense like this. Like let's change it while we are in alpha and all that. So it's also good for the users because after that the API looks better. So
Yeah. So if you want to influence how it looks and how it works for your particular use case, this is the time.
Yes.
Napalm, in answer to my question, this is you're doing secrets management hobby stuff. Hey, they need contributors. And Napalm says, remember, I'm the nerd with the K3s cluster on my shelf.
Nice.
We were just talking about how KubeCon is so great because you get to be like, who else in your life do you get to talk to Kubernetes about? With easily. It's nice.
Yeah, all the nerd stuff.
Yeah, we're all the same kind of nerd.
Yeah.
All right, so let's dig in on these alpha features.
Yeah, maybe let's start with a simple one.
Okay.
This is so maybe let's recap quickly. So if you consider that ESO is a product that we sell, so it has like three main features. One is the read part, so we read something from Vault and store it in a Kubernetes secret, and then applications can use it from their own. The second feature is to generate secrets. So we do that inside the cluster. We generate secrets, and then applications can use the secrets from that point. And the third big feature, which is the one that we're going to talk after the generator one, is the push secret feature, which allows you to read secrets from Kubernetes and store them in a vault.
Okay, I'm gonna need. So the first one was to read and store read secrets from the vault and store as a Kubernetes secret.
Yep.
Yes.
And that's the first one, right?
Yeah.
Yeah. That's how the operator got created. That's the main feature. Yeah.
Okay. And two?
Then generators to generate secrets to be used.
And this isn't generating the Kubernetes resource, but generating the secret itself.
Yeah, it generates a secret that could be like a random password or what have you, like the different strategies that you can use. And then it stores it in a Kubernetes secret resource.
Okay.
So instead of pulling it from Vault, it generates it in memory and stores it as a Kubernetes secret, basically.
Okay. And the third one?
It's like the first one, but vice versa. So we read from Kubernetes and we write to Vault or storage in Vault.
Read Kate's secret, store in Vault.
So Napalm asked if we have a 1Password integration. We have an issue open up about this, and I remember there were some concerns because 1Password doesn't have an API that we can talk to, but they have now another binary that we can use. Or do we? No, I don't remember.
We have one, so I can maybe drop. Can I drop the link in the chat?
You can put it in the private chat, and I'll put it in the.
Yeah, perfect. So we have a provider, and you need to run some sort of middleware inside your cluster to connect with it. That's all in the documentation, so you can take a look at it.
Nice.
I don't think
Napalm and I are.
But it's good. Yeah.
Oh yeah. So you're gonna give a link. Oh, you did already. No, you did you?
I pasted it in the private chat.
Okay, got it. I'll get it right now. Napalm as a regular at the show, and it seems like our interest lineup where I happen to cover technologies right as their interest is peaking in said technology. So that's been fun. So there we go. There's the 1Password automation link is now in the chat.
Yeah, it's a community maintained provider. So we say that it's alpha for the foreseeable future, but like, yeah, you can use it.
External Secrets Operator is its own project, or is it part of Kubernetes?
It's its own project. Yeah, we're part of the CNCF. We're in a sandbox currently.
Okay, cool.
Yeah.
Yeah, that's why we got the stand at KubeCon.
Oh yeah.
Definitely the best benefit in it. It was so valuable to be there and to talk to users.
For sure.
Yeah.
So we are going to start with generators, right?
Yeah, so it's good to circle back. So so the generator is a custom resource that you create inside Kubernetes, and there are different kinds that you can create. So at this point in time, we have, let's say, like 3-ish different custom resources that you can create. One is that allows you to generate credentials for a container registry from one of the big cloud providers. So you have, for instance, AWS Elastic Container Registry or Azure Container Registry or Google Container Registry. And that generator allows you, it basically talks to the Google or generally to the cloud provider API and say, look, please create a credential for me that is short-lived. And then this credential is stored in a Kubernetes secret. So then, in Kubernetes, a pod can reference that as an image pull secret and then can pull that image from that particular registry. So that's the whole idea about that we are able to generate short-lived credentials with ESO for that particular container registry.
So this is so a generator is ESO specific, or is a generator like a Kubernetes specific thing?
It's an ESO specific custom resource. Okay.
So a generator. So you have a custom resource called a generator, but there are three types of generators, or within the one generator custom resource, it can do 3 different things.
Yeah, technically there is a API group for the generators, and you have different kinds of generators that you can create. Okay, so what's the first one called? I don't think we shouldn't list out all of them. I would just maybe just group them conceptually. So we have one that allows you to maybe just call it container registry, because it allows you to create
pull secrets. No, create pull secrets.
Yeah, sure. Why not? Also works.
Because, like, from the cluster admin perspective.
From the use case, yeah. So actually, like I contributed it a while back, and the use case that we've had is that we use Flux to do all the good GitOps stuff, and Flux allows you to store or just pull the manifests from a OCI compliant registry.
Yeah.
And at that point in time, you weren't able to use like service account based authentication. That's why you had to create short-lived credentials and let Flux use those credentials. But that now has changed, and it's not needed anymore. But the use case is still valid to create pull secrets on the fly.
Yeah.
So the second one is a simple password generator that allows to configure a couple of fields like password length, digits, symbols, character set for symbols, uppercase, lowercase, repeating characters, and like all that kind of parameters that you can use, that you can configure to essentially generate a password.
Cool.
And the last one is specific for HashiCorp Vault. It's called a Vault Dynamic Secret.
Yeah,
a
so
Vault Dynamic Secret.
Yeah.
If we have any of the folks that joined at the stand at KubeCon asking for like automated rotation, I guess we can say that we have that for some context, some scenarios with Vault.
And so we're okay. And so it enables automated secret rotation.
Yeah, so the Vault Dynamic Secret one, so Vault, HashiCorp Vault, so this is specific for HashiCorp Vault.
Oh.
Vault works in a way that you have a lot of secret backends, that's how it's called, that allows you to generate and manage credentials for various technologies. So that includes, for instance, MySQL database user and password management. It includes RabbitMQ user and password management. It allows you to issue short-lived credentials for AWS, for GCP, for Azure, and all that stuff. And this Vault Dynamic Secret generator allows you to now basically like talk to all these APIs in the end, and like talk to one specific API and allows it to do whatever that API does. So if you intend to talk to the AWS secret backend, then it will create short-lived credentials for you that you can then use. So yeah, kind of hard to find a couple of points to add to the diagram. Maybe something like allows you to create short-lived credentials via Vault Secrets.
Vault integration.
Yeah, or just generally does for Vault integration. Make it like quite generic. That also works. Yeah, sure.
Yeah.
Improves Vault, HashiCorp Vault integration. Should we say something about pulling secrets for container registries, what that enables?
Yeah, sure. Like 4 image pull secrets. Maybe that should be enough.
Okay, we'll leave it. I think.
Yeah, that
that's
works.
Inferred. In the, yeah. Cool.
It's already describing what it does. Yeah.
Yeah. And then
Do we have anything else on the generators?
No, that's basically it.
Yeah.
As of now. Let's see.
And then push secrets could be very long.
Yeah, let's continue with the second larger block, the push secret.
What are push secrets?
Lucas, you want to go ahead?
Basically, the other way around from the main feature. So we read a Kubernetes secret and we push that into a vault to create a key, to create a secret on the vault.
Okay. Okay.
One sec. And the idea is that you still have to reference the secret store. So we can also say that like the same way that we did with the external secret, like a reference to the secret store. We can put on the push secret and pull an arrow to the secret store.
Okay, got it. I don't know where my face is going to go now. Okay.
And then you have to select the secret that you're going to, like this is a field like a selector. The secret that you're going to consider the source of the value that you're going to push forward.
So it references the secret store, which is referencing a certain vault. And
yes,
then
exactly.
And then what's the second thing?
A selector, like to select the secret on the Kubernetes cluster. This is the source.
Okay.
That selects the secret.
Yeah, and that push secret is a custom resource. Not sure if that's clear.
Okay.
Just to clarify. So push secret is
The,
just
ge-
another custom
the
resource.
generators as well.
Yeah.
We
So
can
generator, yeah.
We can put
Is a
inside a box similar to the secret store and external secret. Yeah, that's true.
This is the source. Got it?
And then the same way that we had a way to reference structured data that we mentioned on external secret, we also have that on the push secret. And you can, now I don't remember, you can push the whole thing or just with the match and select the specific keys.
Yeah, so you can definitely select specific keys. So I want to have that key from the secret.
The match, yeah.
Yeah. But this is still an active development, and we have to look what serialization mechanisms that we want to have, because if you can potentially just read the whole Kubernetes secret, serialize it somehow, and then stuff it into the vault. But we're not we don't have yet all the features in place that allows us to do all the fancy stuff like templating. This is still something that we haven't figured out yet.
The thing is, the APIs of the vaults are in a way very different, and when we start to implement these features, we sometimes run into okay, we cannot implement this for, I don't know, Azure Key Vault. And then it will be super different for this one. And then we have to standardize the fields, taking that into consideration. So the thing that we support right now, as I remember, we can match a specific key, and then we push that value specifically to the external provider.
So it could read a whole secret or match keys.
Right now, just match a key.
Okay. And this thing that you're describing is the same as this third point here, right? It's the third main feature where it reads a Kubernetes secret and stores it in Vault. Okay.
Exactly.
Yeah.
So this one is an alpha feature.
Yeah. If we would write that a bit more, I don't know, describing the whole thing, it would be we read a value inside the Kubernetes secret, and then we push that value into the external provider. And then in the same way that we can define how often it will happen, the same thing here. We had that with external secret, we have this with push secret as well. So how often as well. And from what I remember, that's it. But then if we start drawing...
let's talk about where was the synchronization. So you're using presumably a Kubernetes controller when you're saying it can do it every so often. So it can use the control loop, synchronize with control loop here, synchronize on a regular interval. And then where's the other place?
What do you mean by other place?
You said this has come up a second time, but I didn't write it on the
external secret.
Okay.
The external secret, yeah. Yeah, ESO is a Kubernetes controller running on a loop, on the control loop all the time. So checking for changes, but also reacting on the resources that is monitoring. So if you change external secret, if you add an annotation to external secret, even if the interval is not finished, it will synchronize immediately. So it's a way to force a synchronization. So all the resources are being monitored.
Cool. Excellent. So it reads a value from a secret, a source secret, and it pushes it to the vaults that's referenced in the secret store. And it does that
Yes.
regularly at a regular interval. Cool.
Yes.
Yeah.
And you can configure that interval. Yeah.
Mm-hmm.
Yeah.
Cool.
Perfect. That looks good. Now, what you can do conceptually, if we take a look at the pull-based thing and the push-based thing, you can construct a loop that allows you to, which is something that you shouldn't do ever. I just want to make this explicit. So you can potentially create a loop, so reading from a vault, storing it inside a Kubernetes secret, and then have a push secret, which pushes it back. So this is a horrible idea because both control loops are not synchronized, and there's no locking mechanism between them. So one value will eventually win, and the other value will be destroyed. So there's like no way to, just
that makes sense.
You have to define define a leader, or like you have to define a source of truth. And by constructing a loop, you don't have a source of truth. So this is very, very important to mention when using push secrets. Don't construct a loop ever. Instead, have a well-defined source of truth and use that to pull secrets in or push secrets somewhere else if that is really needed.
That makes a ton of sense. So I'm just now understanding what you're putting together. So this generate secret is the same as this, and this feature is the same as an external secret.
Yes.
Correct?
Yes.
Okay.
Yeah.
Cool. I'm going to make some arrows.
It probably would have been a good idea to start with that. But now we're making a whole lot of a mess in that diagram. But it's fine.
I kind of enjoy it. A mess here and there. Cool. And then this one is this. Cool. I'm happy with that.
Cool. Yeah, it looks good.
Yeah,
Maybe just one more example about the push secrets. So from users I've heard, what they do is that they use, so they have like two clusters in two different data centers, and one of them is the leading cluster and the other one is the following cluster. And in that leading cluster, they run Cert Manager, which you had a very good episode with the that you have from Cert Manager, which was great. Yeah. And then they use Cert Manager to create certificates and private keys and all that stuff. And they use external secrets operator to push that to their following cluster to inject that there. And then they have an ingress controller running in both clusters. And they have then like the same certificate and private key used there. And they can terminate connections on both these load balancers in both data centers. So this is like one example use case how you can use push secrets to transfer secrets from one cluster to another, because the vault conceptually it stores secrets, but like for us, Kubernetes itself is also a vault that allows you to store secrets.
Replicate secrets from one cluster to another. Replicate.
Yeah.
Secrets between clusters. Excellent. What's another use case?
It's the same, like it can be phrased the same way, but like the thing that we mentioned before, like having a management cluster, like a tooling cluster and a workloads cluster. Basically, you just want to create a secret on one of the clusters, but you want the other cluster to be the user of the secrets. But it's just replicating secrets between clusters anyway. Yeah.
When you said leader follower, I thought to myself, I wonder if that's the same as a management cluster with I'd call it a workload cluster, or no, a leader follower is different. Because leader followers for geo-replication.
Yeah, I guess like they're like different terms that have like a lot of overlap with each other, and kind of depends on in which context you apply these terms.
Because in their case, they want the certificates to be used on both clusters, right? Like
exactly.
With ingress controllers and all. But with a management cluster and a workloads cluster, the secrets will be used only on the workloads cluster. Like the secrets are being created on the management one, but like used on the workloads cluster. So that's the difference.
Is leader follower for geo-replication?
From that use case that I just mentioned, yes, that's the idea.
Cool.
I think we had way back when we had the issue for per secret, someone talking about something related to backup, but I can't remember like the specific use case. Do you remember, Moritz?
Yeah, I think the idea is that you have, say, like 2 AWS regions, and you can just pull from one region and push it to another region, like a geo-replication, like of those secrets. Like that would be one option that you have. I guess like it depending on like the type of vault you use, it makes sense or does not make sense to use ESO to do that. I guess if you use like some cloud provider, they already have like that in place and just with a click of a button. So I guess it doesn't necessarily make always sense. Apart from that, you can also use like as a backup mechanism if you have like some say job or something that generates a secret inside the cluster. You can then push it away into a secure vault, and then the rest of the system, whatever it is in your infrastructure landscape, then can make use of that secret. So that could be the case that people use it that way.
Cool. Excellent. How are you feeling? Is there more that we have a little space down here? Maybe a little right here? I'll just peek through somewhere.
I think that was like the vast majority of features that we have, the most important ones.
There are some like, but I don't know if we list them together with the other 3 main features, like aggregating secrets, like things that people ask later, like you have multiple secrets on your vault that you want to like aggregate in the single secret on the cluster. This is something that a feature that was requested, and we made a way for this to happen.
That's fun. Is that its own custom resource? Is alpha?
No. Okay. Well, this is supported.
Yeah, that's part of the external secret resource where you can. So, yeah, the use case could be that you say you have some secret stored in HashiCorp Vault and another secret in, say, 1Password, just for the sake of this example. And then you can use one external secret that points to actually 2 secret stores. And then you can pull these secrets from these 2 sources, but store them in one Kubernetes secret. Oh gosh, saying secret so many times must be so annoying listening to that. Sorry for that.
Honestly, it's better than having more than one term for it and then confusing people
switching over,
you know? Yeah. So a supported feature is a secret aggregation between different vault sources.
Yeah, perfect.
Aggregation. I feel like there should be more G's in there, maybe. That's cool.
Yeah, I want to share 2 more links. I just put one in our private chat. One is about multi-tenancy. I just want to point people towards the documentation where we talk about about like all the problems that you have when you have multiple tenants running within a Kubernetes clusters, and how to use ESO to properly restrict access control and properly enforce tenant isolation. Because this is something that is very, very important if you build the initial platform out, or if you start using ESO in like a larger clusters. This is really needed. And it really depends on the provider that you use, because you have like many different mechanisms that you can use to enforce that tenant isolation. But I think this is a good starting point to point users towards when starting with it.
Yeah.
Cool. Um, and the fact that your resources are either cluster scoped or namespace scoped can help with multi-tenancy too, huh?
Yeah, exactly.
Yes.
Yeah.
Sometimes you have like a platform team or a admin team that like manages most of the stuff for the different tenants that reside inside a cluster, and these tenants don't necessarily want to deal with setting up service account bindings with a cloud provider or setting up, I don't know, vault authentication stuff and all that stuff. So instead, the admin team just takes care of all of that, and as a result, you can have one cluster secret store that is then shared among the different tenants. But you still can enforce tenant isolation by using a policy engine like Caverno or OPA to enforce policies on the external secret resource, so that tenant A is not able to read secrets from tenant B. Simply put.
Mm-hmm.
So yeah,
And then you can have like you can maybe use, like, it's not, you don't exclude one by using the other one. Like, if you can use cluster secret store for something that is global, and then namespaced for the things that are namespaced for team based, and then you can have both secret store and cluster secret store being used in your cluster. Yeah, there are a lot of ways to make this happen. Some are documented, some are not, and like people are always discussing this, yeah, with us. We got like a lot of feedback and a lot of insights at KubeCon, and it was very interesting, like, to have a stand and people coming, oh, we use ESO like this, and sometimes we are not even aware of the use cases, so it's very nice.
Yeah. I mean, right now I'm thinking about the role that Kubernetes plays in all of this, right? Because it seems like just from talking to people, not a lot of people are building necessarily their whole system ground up from Kubernetes. Like they might have existing infrastructure already in different places. But it seems like talking about management workload cluster, you could have a Kubernetes management cluster and then propagate secrets all over your entire estate with ESO, even if you're not a huge Kubernetes shop. Do people do that? Yeah.
Yeah, I think like maybe there's like one more thing that we can talk about is one thing that we didn't do it in the beginning, which is something that we
Like why Kubernetes, right? Like what does Kubernetes add?
actually not that, but the question what advantages ESO gives you compared to like some other tools that we have out there. Like I mentioned briefly, sealed secrets in the beginning. So the biggest advantage with when using ESO is that now, like today, I'm expecting that pretty much everyone is doing GitOps at this point in time. Like pretty much everyone that I know from the companies I work with, also going to CNCF meetups and so on. Everyone uses GitOps. GitOps is everywhere, and ESO is a very good fit when doing GitOps because the only thing that you store in a Git repository is a reference to a secret. You just store where the secret is stored. So it's stored in Vault, it is stored at this particular path, and is a secret with that particular name. And that's about
Yeah.
it. It's a little bit of metadata, but that's about it. It's not the actual secret. Now, when you look at, for instance, sealed secrets, and I not want to start beef with sealed secret, it's still a valid and a very good tool that's been battle tested, and we still use it. So the problem with sealed secret is that you store the actual secret in a Git repository, though it is encrypted. But the actual encryption key, you still have to manage that as well. So you have to store it somewhere, and you cannot store it in a Git repository, so you store it somewhere else. Is it in a Slack thread? Is it in 1Password? Is it stored somewhere on a local machine? So you don't solve the problem of the initial secret that you need in order to decrypt these secrets. So I don't know, are you going to use ESO then for that? Or no, and the other thing is that you have like a specific attack vector that you just cannot fix, or you cannot put any controls in place for that. That is, if the Git repository is leaked, and adversary has access to that Git repository. He has all the secrets, though they're still encrypted. But at some point, it could be that it has a weak key that can be decrypted. Maybe it's just some standard password or a simple 1234, or what have. And maybe it's just a crackable algorithm at some point in the future. Then like all the secrets are gone. So this is a high risk that you cannot really put controls in. From what we've learned from the past incidents that we saw at Circle CI and Travis and so on, that it is very possible that all of your source code is going to leak at some point, and this is a problem if you store secrets in there. So but this is just to mention that.
So you said there are two advantages. One's good for GitOps, and then will you help me succinctly say that second one?
Good for GitOps. You only store references, or is that something that you wrote it down?
Yeah. Yep. And
secrets are like recurrently synced. In my opinion, that's very nice for rotation. And when we look at security, a lot of times we focus on prevention, but like this is very nice for response, because if you have secrets leaked and this is an incident that happened today, you just rotate everything now. And you have a mechanism for this to propagate, and you don't have to worry about creation, like making people aware of things. Maybe you can automate this and just press a button.
Yeah, that's the strongest argument for using a vault to store all your secrets in, instead of storing them in the Git repository. So then you can also automate the lifecycle for it. Yeah, that's a good one.
Yes.
Yeah.
So secrets regularly synced, which has the advantage of automating the lifecycle. Yeah.
Like automating and decoupling the lifecycle from.
Yeah, I like that.
And in my opinion, the quality of life, like it's easy to use. I think it makes it easier to deal with secrets, even from an application developer perspective. Everything is in place, and you already like figured out RBAC and everything, like how things should be secured. Like creating a new secret for a new, I don't know, API that you have, it's very, very easy.
So we talked kind of before, would you say it's kind of difficult to set up? I mean,
yes,
probably no worse than any other secrets management. What?
ESO is quite easy to set up. It's just a Helm install, and that's it.
Okay.
So then you have it running, and then you need to figure out what the best way is for you to authenticate with the Vault, which is probably service account-based authentication. But that's about it. And then you need to figure out all the multi-tenancy stuff. But that's I would say this is well documented, and if something isn't, then just ask us in Slack. We're happy to help. But I would say it's very easy to install.
Okay.
But of course, I'm very biased.
You do have a lot of love for this project, and it seems so useful and important too. So I'm going to add easy to set up.
And also, like maybe one more thing.
Okay.
If there's still place.
I'll find room. I'm a professional.
So when you use ESO, you have the advantage that if your vault goes down, your secrets are still inside the cluster, and you're still able to use them. Which sounds like a minor thing, but it's like sure what the English term for that is, but it's sort of a backup, because like you have the source of truth is in Vault, and that is replicated inside the cluster. If Vault isn't available anymore, the state is still inside the cluster, and your system probably is able to continue to function.
And I guess the inverse is true, where if the cluster goes down, when you need secrets later, they're just in Vault and easy to pull back in.
Yeah.
Yes.
Do you think it's enough to say secrets are backed up, or do you prefer to say in case of Vault failure?
secrets are available. If
I would add that with in case of vault failure. I think that's an important point.
Yeah,
yeah.
I see that because Vault isn't replicated like Kubernetes is, maybe. I suppose it can be.
Yeah.
All right. I have a. All right. Cool. If there's anything you want to add, let's add it. If not, the next step is to, I'm going to recap everything we've talked about and make sure I have a clear understanding. And we'll add or change anything as I go if something's not quite right. Are we ready for that step, or is there something else you want to teach in this moment?
Maybe just one or two sentences about like I briefly touched on the alternative options that you have available. I just mentioned the sealed secrets and external secrets operator, but there's also a third one which I haven't mentioned yet, which is the secret store CSI driver, which has a fundamentally different concept, and I'm not going to explain that. Just I quickly wanted to mention that briefly. Maybe that's also a good candidate for another episode. We're in contact with the maintainers there and trying to find a way to interoperate the different operators, make them interoperable and maybe reusable. But
that's cool.
Just to mention that it's like, yeah.
What's it called again, please?
Secret Store CSI driver.
Secret Store.
Is that right,
CSI
Lucas?
driver.
Is that right, Lucas?
Yeah.
I always get that wrong. Okay, cool.
It's right.
Secret
Store CSI.
Okay.
Driver.
Yeah. Got it.
It's right. Yeah. Yeah, we always have users asking for integration between these two projects. They have like, I think we don't have space to explain it, but yeah, I agree with Moritz. If we like, they have a channel on Slack as well, and I think it will be a very good episode as well if you can.
Noted. Right now, I'm focused on covering CNCF projects or Kubernetes related, CNCF. I have to limit the scope somehow.
They are a Kubernetes project.
Oh,
they are under CNCF because they are a Kubernetes 6 sponsored project. Yeah.
Oh, okay. I'll put it on my list. I'll remember. And you're welcome to tell them to reach out to me too. I do I thought y'all were the only in the space, and it is nice to have more than one to compare it to and hear how different people are approaching the same problem. It gives a more complete picture.
Yes.
All right. Are you ready for a recap?
Yes.
Yeah.
Okay. As you can imagine, secrets management used to be a mess. There's so many aspects of secret management to consider: creation of secrets, rotation of secrets, deleting secrets, distributing secrets, accessing them, what happens when they leak. There are all different types of secrets, like you said in another language: credentials, tokens, passwords, API keys, encryption keys, certificates, which are kind of the same thing, maybe. Storing secrets, transmitting secrets, the life cycle of secrets. How many times have we said the word secrets already? And we're only at the beginning of the recap. So a lot of this is solved with the technology called a vault. And so a vault gives a central place in the system to store and manage secrets and deal with all of these things. So a vault's a system that stores secrets safely, and then it has an API to interact with it. So the external secrets operator is built on top of a vault. And so it is providing a way to access and interact with the vault using Kubernetes. To jump to the conclusions a little bit, being able to interact with it via Kubernetes is important. It helps you be able to define secrets declaratively in a way that's compatible with GitOps. And it also, you can use the Kubernetes control loop to make sure your secrets are regularly synced to help automate and decouple the lifecycle. But we're going to talk about that again at the end. Spoiler alert. So anyway, external secret operators are built on top of a vault, and then the attributes that secrets have in general, you have to worry about their expiration date. You need to worry about how they're created, manually versus automated. Secrets might have dependencies. You need to worry about that, and who's going to consume the secret, a human or a process. So external secrets operator is a Kubernetes operator that talks to a Vault API and retrieves secrets, stores those secrets in Kubernetes, and manages the lifecycle of a Kubernetes secret. So there are many topologies here, but we drew out a simple example. This example, we have the vaults and we have ESO, our ESO operator. So the ESO is going to read the secrets from the vault and pull that secret into its own memory, and then it's going to create a Kubernetes secret resource that is a reference to the secret in the vault. That's correct. So the literal actual secret isn't necessarily in the resource, right? Yes.
Yep.
No, but this the final Kubernetes resource has the secret.
Okay, got it.
Yeah.
Okay, so this is the literal. That makes sense because we talked about if it could go down, your secret is still in the cluster. Okay, so then basically it does the work of putting the actual vault secret into the Kubernetes resource secret. But this is a very simple example. You can also do much more complicated things that might enable multi-tenancy or geo-replication, for example. And then, as we'll talk about it a couple more times in a couple more ways, you could also pull secrets from Kubernetes and push it to Vault, but we'll get to that. So then we talked about two important ESO custom resources. One is the secret store. So this tells the ESO operator how to communicate with Vault. It does the connecting between authentication. So it represents the Vault in Kubernetes, which provider, authentication, provider-specific configuration, and then it can be namespace scoped or cluster scoped. So you can access that Vault either cluster-wide or within only a certain namespace. Then you have your actual external secrets, which references your secret store. But it says, take the secret from this particular secret from this Vault and make it into a Kubernetes secret with this name. So other things you're going to want to configure besides that main functionality is how often you're pulling the secret, how often it's synced, how you might template the secret depending on who's going to consume that secret. In the end, you might need that secret to look different and just in a format way. And then it's going to contain a reference to the secret store. It can pull a dynamic list of secrets. It can be namespace scoped or cluster scoped. It can extract structured data from a vault. So you can, instead of pulling an entire secret, you could pull, for example, a key from a secret. It syncs at regular intervals. And then at the very end, we said, I'm not sure if this is an external secret resource, but you said that you could do secret aggregation between different vault sources. Does that happen within the external secret?
Yeah, exactly.
Yeah.
Yes.
Cool. So that would be one more thing it can do. In fact, I'll just point it over here. We'll have another arrow. That's what this board needs. No, it's great. It's great. So that's an external secret, and this is all the supported current main functionality of ESO right now. But ESO is expanding and has a couple pretty great alpha features coming. They're currently alpha. And so we talked about reading from Vault and storing it in a Kubernetes secret, which is the main supported thing right now. But it could also do these two alpha things, which is generate a secret and store it as a Kubernetes secret. And it could also read a Kubernetes secret that already exists and then do the work of storing it in Vault. So we talked about the custom resources, the alpha custom resources to be able to make these two things happen. The first one's called a generator. It is a custom resource that you can create within Kubernetes, and you can do three different things with a generator. You can pull secrets for container registries. You can generate passwords, and you can add a lot of parameters for what exactly you want that password to look like, how many characters, uppercase, lowercase, symbols, all that jazz. You could also, specific for HashiCorp Vault, you can, there's one called Vault Dynamic Secrets, and without getting into the nitty gritty of how HashiCorp Vault works, well, we just decided to say it improves HashiCorp Vault integration, and I'm happy with that. Then we have another custom resource and the third main feature of ESO, which is push secrets. And that reads the Kubernetes secrets and stores it as a secret in vaults. And so again, it's going to reference a secret store because it needs to have that knowledge of external system, that the vaults, the external, that's external to Kubernetes. It's going to select a secret within the Kubernetes cluster. That's the source. And then it'll read a value from that secret, not the whole secret, and pushes that to a vault. And again, it takes advantage of the Kubernetes control loop to be able to do synchronization. So you can say how often you want that to happen. So we talked about use case examples. You might want to replicate secrets between clusters. And there are 3 reasons you might want to do that. One is if you have a leader-follower situation in geo-replication, for example, you would want to replicate secrets between those 2 clusters. Or if you have a management and a workload cluster, you might want to replicate secrets between those. And you also might want to use it as a backup mechanism. And and then finally, we went over our list of benefits for ESO. It's good for GitOps. So it references, well, for one reason, it's because it's making it into a Kubernetes resource, and GitOps is going to work with Kubernetes resources, tools like Argo CD and Flux. For another reason, it references a secret, not the actual secret. Tell me more about that, because we did just say it's the actual secret.
Yeah, so in the custom resource, so in the external secret resource or in the secret store resource, you never have the plain text secret there. It's just a reference to that secret inside the vault with a specific name, prefix.
Got it.
And the Kubernetes secret, the final secret created by the operator, this will never go to Git, only on the cluster. It's just created by the operator. Got
it. Cool. Thank you for explaining that. And then the secrets are regularly synced. That's another advantage. So that helps with automating the lifecycle and decoupling the lifecycle. It's easy to use and easy to set up. And secrets are backed up in case of vault failure. Those are our big advantages. How do you feel? Is there anything you want to add?
That was impressive that you kept like all of that stuff in your mind. That's that's a very good summarization. I'm very impressed. That's pretty well put. Nice.
Thank you. It takes good teachers for me to be able to pull that off. So thank you both for being amazing. This has been really fun.
Yeah. Very nice.
You happy, Lucas? Anything you want to add? Yeah.
I'm using this link when it's published, just to show people like everything summarized, and it's perfect. Yeah.
My plate's kind of full, but I think it would be nice to be like, here's where the recap starts. If you don't have like 2 hours to watch the whole episode and how we got there, let's like start at this moment. Oh, yeah, we should probably figure that out. But yeah, this has been really, really fun. You all both said that you've watched an episode before. Have you watched it to the bitter end? Because the thing we do at the end is we dance when we say goodbye. Are you ready? You're like,
oh, I think I did.
I'm just going to replay the intro music. You guys both, all you have to do is move your shoulders. There's not much of you in the frame. Yeah, there you go.
Let's go.
And we're gonna say goodbye. Thanks so much, everyone, for joining. Thanks those who watched the recording. I appreciate you.